Hi, my name is Joel Ort with Miller Electric Manufacturing Company. Today we're going to show you how to weld with the self-shielded flux core welding process in the flat, horizontal, vertical, and overhead positions. Unlike the MIG process, flux core welding does not need a shielding gas. The reason for this is that the wire is hollow, and on the inside of the wire there's a flux, and that will react with the weld pool, which protects the weld pool from contaminants. This makes it the ideal process for outdoor welding. It's always a good idea before you start your project to practice welding on some material that's similar to what you're going to be welding on. This way you'll achieve the results that you want. And also, before you begin, have the proper safety apparel on, such as a jacket, some safety glasses, long pants, some steel toe boots, a welding helmet, and some welding gloves. For the drive rolls with flux core welding, you're going to want to use the knurled groove drive rolls. Otherwise, will not feed the wire properly if you use the smooth drive rolls on there. And also for flux core welding, you're going to want to change your polarity to electrode negative. That's electrode positive for MIG welding, but for self-shielded flux core, you need electrode negative. Flux core welding produces a lot more smoke than typical MIG welding. It's a good idea to make sure you have adequate ventilation. If you're indoors, just make sure you turn on a fan and open a door. The wire stick out should generally be about 1/2 to 3/4 of an inch from the contact tip, possibly a little longer for tight joints. Gun travel for flux core varies a little bit differently. Instead of pushing the gun forward, what you'll need to do is drag the gun or backhand weld, similar to stick welding. For a typical butt weld or flat position weld, your gun should be at 90 degrees to your workpiece and 10 degrees tilted back, welding with a slight weave, pausing side to side to avoid undercut. With flux core welding, you're going to have slag that's left behind when you're done with your weld. Different wire types produce slag with different properties, but either way, all of it must be chipped, scraped, and brushed off completely before you make a second pass or make multiple passes on thicker material. For a typical T-joint, you're going to want the gun at 45 degrees or an equal distance from each piece. And on thicker pieces, you may want to weave the gun, pausing on each side to avoid undercut. For a lap joint, you're going to want your gun at 60 to 70 degrees, directing most of the heat toward the bottom of the workpiece. You make one straight weld. For the typical horizontal weld position, the first thing you'll want to do is turn your welding parameters on your machine down about 10 to 15%. You also want to angle your gun upwards towards the weld puddle at around 10 degrees to accommodate for gravity. For the vertical welding position, again you'll want to turn your machine parameters down by 10 to 15%, and you'll want to angle your gun at 5 to 15 degrees up at the weld puddle. You're going to want to weave from side to side, pausing on the edges to avoid undercut. And also with vertical welding, you can weld vertical up or vertical down. Vertical down will give you less penetration and is much better for thinner metals. Vertical up will give you more penetration for anything 1/4 inch or above in thickness. The overhead welding position is the most difficult to do. Try to avoid it if you can, but if you need to, again you'll need to reduce your welding parameters a minimum of 10 to 15%. Try to maintain fast travel speeds, and then you can avoid having the weld pool fall from the joint and onto you. Self-shielded flux core welding is a great process to learn. It enables you to weld outside, and you don't have to worry about your shielding gas blowing away. But like any other type of welding, a lot of practice and some patience will go a long way to making a good quality weld.